Hey guys, welcome to 10.2a Arithmetic Sequences. In this video we are going to be talking about the arithmetic sequence, which is a different type than geometric, as we're going to read below here. So an arithmetic sequence is a sequence in which the difference between consecutive terms is constant. We call this the common difference, and before with the geometric difference we were always multiplying by a common rate. This time we are going to be adding a constant. So this time we are going to be adding a number to get to the next term for these. Another new part that we're going to want to be aware of is a of 0. This is the 0 term, the term before the very first term. Some examples of arithmetic sequences would be as follow. 3, 7, 11. Notice to go from 3 to 7 and 7 to 11, we would add 4 for both of those. So the next term is going to be 11 plus 4 is 15, and then 15 plus 4 is 19. Now this one's a little bit trickier because it's going down, but we can still add a value that would decrease, and that's going to be just a negative number. So we are going to add negative 5 to this one, because 8 plus negative 5 is going to give us 3, 3 plus negative 5 is going to give us negative 2. And basically it's the same thing as subtracting when you add a negative. So this is going to be negative 7 and then negative 12 after that. Now, just like with geometric, it has to be consistent through all of your terms that you can see. So this wants us to decide whether each sequence is arithmetic. So this first one, we're going from negative 10 to negative 6. So that would be adding 4. And then negative 6 to negative 2, that would still be plus 4. But once we go to negative 2 to 0, that's only plus 2. Since we don't have a consistent term that we're adding, this is going to be a no. Now this next one, 5 to 11, again we're adding, and that would be plus 6. 11 to 17, plus 6, plus 6, plus 6, and it's consistent all the way through. So this would be yes. And then rather than r, we're talking about a constant that we're adding, so d equals 6. That's going to be our new variable for the arithmetic that we want to talk about. All right, here's our first example. The rule for the nth term of an arithmetic sequence. The nth term of an arithmetic sequence with the first term a of 1 and a common difference of d is given by the formula a of n equals d times n plus a of 0. So the big thing to identify on this one is your d, the common difference, and then a of 0, the term before a of 1. So we want to write a rule for the nth term of this given sequence. So a of 1, notice, would be the 32. So the difference is going to be, how do we go from 32 to 47? And this one we would add 15. So it's 15. But now to find a of 0 is equal to a of 1 minus d. So, because we can just go backwards, do the opposite. So a of 0 is going to be 32 minus 15. So a of 0 is going to be 17. Pretty easy to find. So then the general rule, if we fill in this part right here, is a of n equals 15n plus 17. That's our general rule. And then when we find a of 12, it's the same as when we did geometric sequences. It's 15 times 12 plus 17. And that is going to give us 197. Similar for this next one, but notice we're going down. When you're going down, that's going to tell you that you're probably adding a negative as your common rate, or your common difference, excuse me. So this one, I'm going to actually start by thinking about the common difference, and it's going down by 5. So it's going to be negative 5 as our value. So a of 0 is going to be a of 1. This is our a of 1. 30 plus, or excuse me, skipping a step, minus a negative 5, because we would subtract, but this would end up being plus, so it's going to end up being, because two negatives would make it a plus. So we get 35 for the a of 0. So our formula is a of n equals negative 5n plus 35. And then a of 10 plug in 10 in place of the n, you would get negative 50 plus 35, which is negative 15. Pretty straightforward for those ones. Now these are the ones where we need to do a little bit more work. We want to find the nth term given a term and a common difference. So one term of an arithmetic sequence is a of 8 equals 50, so the 8th term in the sequence is 50. The common difference is 0.25, and we want to write a rule for the nth term. So what we do for these is write out the general formula, same one every time, and then just fill in what you know. So we're going to use a of 8 equals, the difference is 0.25, and a of 8 is going to give us 50, so I'm just going to write n for right now. So now I'm going to replace that n with 8 and the a of 8 with 50. It's going to be 50 equals 0.25 times 8 plus a of 0. And the last thing we need to solve for is that a of 0. So we get 50 equals, and then what ends up happening here for this next one is when you multiply 0.25 times 8, you just get 2 plus a of 0, and we want to get rid of that 2, so we're going to subtract. So 48 is our a of 0 term. So that's everything that we need to write the final answer as a of n equals 0.25 n plus 48. All right, a couple more. This next one is just like example 4. One term is a of 5 equals 30. The common difference is 4. Write a rule for the nth term. So we're going to do the exact same thing. Write out the general formula. It's good to practice this just to think about what you need to find. So this one's going to be a of 5 equals, the common difference is 4, n plus a of 0. So we are going to do 30, because that's what this equals 4 times 5 plus a of 0. So 30 equals 20 when we multiply that out. Subtract 20. You get 10 equals a of 0. Don't forget the last step though. Plug it back in. So 4n plus 10. We got the common difference is 4, and then we solve for a of 0 to be 10. Now this last one is a little bit more work, because this is the one where we don't know the common difference, but we do know two separate terms. So this is where we're going to have two parts. I like to divide it up. I also like to think of these as coordinate pairs. So this one is going to be 5, 10, and this is going to be n and a of n. And then we're going to have 30 and 110, and again, it's going to be n and a of n. And we're going to plug it into that general formula. So the general formula I can just write off to the side here. D times n plus a of 0. So then we are going to get, so on the left side, we're going to get 10 equals, don't know what the difference is. We know this is going to be, oh no, I had that right. That was 10. And then this is times 5 plus a of 0. And with this one, you're always going to want to solve for a of 0. So we are going to subtract 5d, which is what we would get if we put those together. So on the left side, we're going to have 10 minus 5d equals a of 0. Then on the other side, we are going to get, now using the second coordinate, 110 equals d times 30 plus a of 0. Just like before, whenever we've had these problems, we take what we solve for on the left side, and we're going to plug it in on the other side. So we're going to get 110 equals 30d plus 10 minus 5d. And then we just need to solve for this. So 110 equals 30d plus 10 minus 5d, and then we're just going to put those together. We're going to get 110 equals 25d plus 10. I'm going to subtract 10. And just like normal, these are going to usually work out to be really nice numbers. Divide by 25, and we get d equals 4. So our common difference is 4. And then we got to plug that back in to solve for a of 0. So off on the left-hand side, I would do 10 minus 5 times 4. 10 minus 20 is going to give us negative 10. So that's what a of 0 is. So then the general rule is going to be a of n equals 4n minus, we got negative 10. Or you can put it as plus negative 10, same thing. But that's the general rule. So now we want to write the rule for n for which a of n equals negative 2. So on this one, if we said negative 2 equals 4n minus 10, we want to solve for n. So we're going to add 10 to both sides. You get 8 equals 4n, and we do get a nice number here. Divide by 4, and you get n equals 2. All right, that is it.